Hi, welcome to physics lesson. Today we start chapter 4.1 magnetic forces and magnetic fields. Let's begin with a magnet. Magnets can attract iron object. The force related is called magnetic force. And we can find two poles for the magnet, south pole, north pole. For the magnet, there are three different types of magnet we can find in the physics experiment: bar magnet, slab-shaped magnet, ring magnet. Similar to electrostatics, light charges repel and light charges attract. Now, for the magnetic force, light poles repel. So here you see repulsion. Okay, and light poles attract. Attractive magnetic force. For some material that can be attracted by magnet, we call this magnetic material. For example, iron, steel, magnetic material. For the material that cannot be attracted by magnet, we call this non-magnetic material. For example, aluminium, copper, and also aluminium. Okay. But what is the secret of the magnetic material? Before answering this, we have to think about the structure of a magnet. So maybe you can jot down notes here. If we have a magnet with a south pole and north pole, okay, in physics we would like to draw an arrow to represent. Okay, the tip of the arrow means north pole, and the tail of the arrow means south pole. Consider a large magnet. It has many tiny small magnet inside. Okay, so we can draw like this. Okay, now the question time. If this magnet is broken into two pieces, what do you think? Choice 1, it will become two magnets with one pole only. Choice 2, we have two pieces, but for each have both north pole and south pole. Okay, the answer is B. Okay, do you know why? You can see this part. It consists of north pole and then south pole. Okay, and the part, similarly, we have north pole and also south pole at the back, right? So we can find, we know the structure of magnet will be this. But how about not? So we come back to the story of magnetic material. So if an object, it's not a magnet, an object only, suppose it cannot produce magnetic force. So what do you think about the structure inside? Now we have the same story. It consists of many small tiny magnets inside, but the arrangement of these tiny magnets is randomly arranged. They do not have the same direction. Okay, so the net magnetic force will be 0. No net magnetic force. However, for magnetic material, if I put a magnet nearby, next to the object, for magnetic material, the tiny magnets inside will be rearranged again. They will align in the same direction. Okay, so now what can you see? You see, we have north pole and south pole for the object. Okay, This process is called magnetize. Only magnetic material can be magnetized. Okay, so this is the secret of magnetic material that can be attracted by a magnet. Okay, if I put away the magnet, okay, then the object, the small magnet in the object will be changed. It would return to the original arrangement. No net magnetic force can be produced. Okay, now so this is magnetic material. Now we go to the second point. Magnetic field. Similar to the electric field, if I put a magnet here, okay, we will imagine that the region around the magnet, it exists magnetic field. Okay, magnetic field exists around the magnet. For the magnetic field, in physics, we use B field to represent. Okay, B field. We do not use M field. B field. Okay. We can find the magnetic field pattern by the experiment. Okay, so maybe now we look at the video.
Using sticky tape, fix a bar magnet to the underside of a perspex board. Sprinkle iron filings onto the board and tap the board
This
gently
is how we
with
use
a
our bar
pencil.
magnets for the experiment.
Observe the iron filings pattern produced.
We can see the magnetic field pattern.
Place two
By
bar magnets
using
end to end with
iron
unlike poles facing
filings.
each other. Sprinkle iron filings onto the
Okay. Second experiment.
Place two slab-shaped magnets with
We
unlike
use
poles
two
facing
slab-shaped
each other.
magnets.
Place a perspex board on top. Sprinkle iron filings onto the board and tap gently to produce
Sprinkle
a
the iron
pattern.
filings onto the board so we can see the magnetic field pattern again. Actually, you can draw the, we can have the three-dimensional magnetic field. This is a funny experiment.
You can see the two-dimensional magnetic field patterns in the textbook. But can you imagine what the magnetic field pattern looks like in a three-dimensional space?
This is 2D magnetic field.
I will show you
about
the three-dimensional magnetic field pattern of a bar magnet with the apparatus shown. Put a bar magnet inside the test tube and rotate. You can see the After a while, the iron filings inside the bottle will be attracted by the bar magnet and settle into a special pattern. Observe the pattern
We
carefully.
only have 2D magnetic field. We don't need to draw a 3D magnetic field. Okay, Now you need to know how to describe the experiment. So maybe you underline the keywords. Now we fix a bar. We fix a magnetic bar. A bar magnet under a board, and then sprinkle. Sprinkle is a keyword. 抌落去啊 sprinkle iron filings onto the board. Take gently. 蹬下佢。Okay, with a pencil or with a finger, you can see the pattern of magnetic field. Okay, with one bar magnet, two bar magnet, unlike poles face each other, two bar magnets. Okay, light poles face each other, and we need to know how to draw the magnetic field instead of just showing the pattern. So for the magnetic field, for a bar magnet, north pole, south pole, okay? So we imagine the magnetic field come from north pole. So we draw like this and go back to south pole, okay? So what is the difference between experimental result and our drawing? The answer is direction. Okay, for a drawing, you need to show the direction of magnetic field. Okay, but the experimental pattern cannot show you this. And secondly, two magnetic bars, we can also draw the magnetic field. Okay, start from N to S. Okay, again, two north pole, so we know come from north, but here in the middle we found that point. Do you remember the name? Yes, no magnetic field. It's neutral point. Okay, neutral point. Okay, so this is our drawing of magnetic field. You should know how to draw this. We can find this in examination. Okay, 3D is not necessary. And for the slab shape magnet, so for the top view, we can see NS. Okay, so for the magnetic field, again, start from N to S. Okay, so we found in this region, we found parallel horizontal lines. Okay, that means uniform B field. Okay, and there are some etching effect. Okay, so this is magnetic field between two slab shaped magnet. So you agree with the experimental result, you see. Okay. Another very important thing is to use a compass. So what do you know about compass? Compass is a circle, right? With an arrow inside. The tip of the arrow means north, points to the north, right? And south here. So this is the structure of our compass. We can also use an arrow to represent. The needle of the compass is a magnet. Okay? So if I put a magnet here and then put a compass in this direction, what is the pointing direction of the compass? 3, 2, 1. Okay. So point to the left. Okay? Because you see north pole should attract to the south pole. Okay? And then how about this position? What's the pointing direction? 3, 2, 1. Okay, so again, point to the left. Because you see the tail of the arrow, the tail of the needle of the compass is South Pole. Okay, South Pole. So it should attract towards the North Pole. And one thing very important is to study about the relationship between magnetic field and pointing direction of compass. So now we draw the magnetic field produced by bar magnet. Okay, it is. So what is the relationship between them? Okay, the answer is they have the same direction. They have the same direction. The pointing direction of compass actually have the same direction as magnetic field. Okay, so if I put a compass here, 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 what is the pointing direction? Okay, so you will be have the same direction as magnetic field. Oh, sorry, wrong drawing. North to south, right? North to south. Okay. So, this is important to use compass in chapter 4.1. Okay, now we go to the last part of 4.1. That is to study the Earth's magnetic field. The Earth's magnetic field. Now we know the compass points to the north of Earth. So what does it mean? Geographically, North Pole. Okay, geographically North Pole. But in physics, oh, interesting. It will be South Pole. Now because you know, magnetic field we can draw from North Pole. The Earth actually behaves as a giant magnet, a large magnet. Okay, the magnetic field starts from North Pole, here, and then go to the South Pole. Okay, so if I put a compass here, it has the same direction as magnetic field. Okay, so in geography we know is North Pole. However, in physics, it will be South Pole. The keyword is South Pole of Earth magnet actually is in the north. This is amazing and very interesting. Please remember this. Put a star here. Okay. Okay, this is the end of chapter 4.1, magnetic field and magnetic force. Okay, now maybe you try chapter 1. Question 1, 2, 3, 4. Have a try. At the end of this video, I will show the answer to you. Okay, try. And then practice 4.1. I suggest you to try question 2. Okay, question 3. 6, 7, 10, and 11. Okay, so maybe you try it now and don't look at the answer before you have done this. I will show you the answer very soon. Okay, now I'll show you the answer. Okay, this is trap point answer. And also, this is a practice 4.1 answer. Question 1 to 5. And then 6 to 7. Question 8. And question 9. Okay,